So let's look at some applications that relate to linear equations. So we have scientists are conducting an experiment with a gas in a sealed container. They're measuring the mass of the gas, and they realize that it's leaking, and it's conveniently leaking in a linear way. So with that we know we can use a linear equation. So each minute they lose 8.8 grams. So you can think in terms of how the mass is changing. It's decreasing by 8.8 grams per minute. And this kind of idea of rate of change, that's going to relate to slope. So I'm just going to put a little m by there because this idea of grams per minute is rate, and that's going to relate to slope. 7 minutes since the experiment started, the remaining gas had a mass of 334.4 grams. So this right here is going to relate to a coordinate where we have this relationship of 7 minutes connecting with 334.4 grams. So we have this idea of slope, and we also have this coordinate coming through. So we're going to let x be the number of minutes that have passed, and y is going to be mass. So we want to find a linear equation. So let's think about that slope that we were talking about up there. So our rate of change. So it's a loss. We're losing 8.8 grams. That means that this function should be decreasing, which means our slope should be negative. So we should have this negative slope, and this rate of change is 8.8. So that right there is just going to be our slope, negative 8.8. So in terms of our model, I have y equals negative 8.8x, but we don't know what the intercept is. But what we do know is this coordinate that they were telling us about, where we have 7 minutes, so that's going to be our x value is 7, and then the mass would be our y value, which is 334.4. So what we'll do is plug that in to the equation and solve for b. So y is 334.4 equals negative 8.8 times x, which we're letting be 7, and then plus b. And now we're going to solve for b. So if we multiply negative 8.8 with 7, we should get a negative 61.6 out. Add 61.6 to both sides of the equation, and that should be 396. So our linear equation is y equals negative 8.8x plus 396. With these, be careful. Sometimes students stop at this b equals 396 because you get there and you're like, yay, I solved it, I'm done. Not quite. Always make sure, especially with applications, to check what they were actually asking for and that you have answered it. Alright, how much gas would be left after 31 minutes? So what we want to do is look at x equals 31. So we're going to take the equation we just found, y equals negative 8.8, and plug in 31 for x. And we can just type all of that into the calculator there, and it should be 123.2. And with our applications, we should have our sentence answers. So there would be $123.2 grams of gas left after 31 minutes. If the linear model continues to be accurate, how much time must pass for all of the gas in the container to be gone? So, how much time? So we don't know what x is. What we do know is the mass of the gas in the container. Well, for it to be gone would mean that the mass would be 0. So we want to plug in 0 for y. So we're going to have 0 equals negative 8.8 times x plus 396, and then we'll solve for x. So subtract 396 from both sides, divide by negative 8.8, and we'll get x equals 45. So the gas in the container will be gone. After 45 minutes. Alright, so there's a word problem for us, and we'll look at a few more of these in our participation as well.